Acid-base reactions. This is a subcategory of double displacement reactions themselves, but it uses acids and bases as reactants. Alright, now, typical example includes hydrochloric acid being mixed with sodium hydroxide. The key premise is that one of these substances is an acid, and by now, hopefully, you do know that the substances that start with an H and are neutral overall are your molecular acids. Sometimes they can be polyatomic, sometimes they can be binary, but starting with that H tells you that you are most likely than not dealing with an acid. Bases, on the other hand, not entirely, but usually the common ones do have an OH associated with a metal. In other words, you have a hydroxide ionic substance. Those ionic substances are bases. And the premise is that you will produce water as the acid and base neutralize each other, and you will also form a salt associated with the cation of the base and the anion of the acid. Alright, now typical acids and bases that you should be aware of are HCl, HBr, HI, HNO3, HClO4, H2SO4. All of those acids as listed are your strong acids. You can also use acetic acid, which is shown here at the very end. This is a weak acid in comparison, but it is an acidic substance nonetheless. By no means is this list comprehensive. There's plenty of other molecules that can behave in acids, and as you will learn in future chemistry courses, there is actually quite a range for acidity, and even substances that we normally don't consider as being acids can behave as such under the right conditions. But for now, we're only considering substances dissolved in water, which creates a constraint as to what can be an acid. So these substances here are the common ones that we're going to interact with, but keep in mind that they are not the only ones. On the other hand, hydroxide salts like lithium hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, barium hydroxide, these all correspond to bases. They all have hydroxides. And the presence of OH minus characterizes a substance as being a base, as long as you have a metal associated with it. The presence of H plus, basically the first element in the molecule, in the neutral molecule, represents an acid being there. Now, reactions that you are going to carry out experimentally are those of acids and bases, the ones where you neutralize an acid with a base or you neutralize a base with an acid. Typical reactions of this sort are known as titrations, and we will talk about that type of reaction in more detail in the upcoming lectures. For now, we're going to concentrate on the balancing process of an acid-base reaction. So here we have nitric acid reacting with barium hydroxide. So we have an acid reacting with a base. And what this will form is water as well as a salt. The salt itself is the product of the double displacement reaction. Barium, which first has hydroxide, will end up partnering up with nitrate. And using the charges, you should find out that barium nitrate is the structure shown here on the right side of the equation. Alright, so we have water and a salt. Now we need to balance the equation. Notice that there is two hydroxides within barium hydroxide. You only have one water on the product side. What you need to do is multiply the waters by that amount. And also notice that you have two nitrates on the product side, so notice that now I put a 2 in front of nitric acid to balance the nitrates. But because you do have two hydroxides present, you're going to need to have two waters. That's another way to look at this that kind of simplifies the process a little bit. And at this point, your equation is balanced. Now I'm going to show you a few other reactions that are also acid-base reactions, but they do also characterize themselves by the fact that they do form gases. You may have already seen some of these reactions in the laboratory. and you're required to remember a few of them. Now, specifically, sulfite salts, like lithium sulfite. If you do have sulfite, that's actually a base. Okay, so metal sulfides are bases. And as long as you react this with some acid, like hydrobromic acid, you will generate not only a salt, specifically lithium bromide in this particular example, but you will generate also H2S. Okay, this comes directly from the double displacement of the cations, right? H gets replaced by lithium, lithium gets replaced by H. This is a double displacement reaction at its core. Now the H2S molecule is actually not ionic, it's molecular, and it's small enough that it turns out to turn into a gas. So this is one particular reaction that could form a gas. Now this is not something that we typically have you do in labs because H2S is rather toxic and quite smelly. Another reaction, now this is a lot more common one that you have probably performed in the past, is the reaction of carbonate salts. Either carbonate or bicarbonate, both of which behave as basic substances, if treated with an acid like HCl, they will produce a salt, specifically sodium with chloride, that's your salt, and they will produce water, but in addition to that, you will form a gas, carbon dioxide specifically. So anytime that you mix an acidic substance with a carbonate salt, you will see bubble formation, gas evolution, and specifically that gas is going to be CO2. This is one that you definitely need to remember. Formation of CO2 gas from carbonate and bicarbonate will be something I will expect you to remember. And notice that in this case, we also form water and we also form a salt as part of an acid-base reaction. A similar type of reaction is one in which instead of using carbonate or bicarbonate, we use sulfite or bisulfite. The only difference here is that instead of carbon, we now have sulfur, but the premise is still the same. React the basic sulfite or bisulfite with an acidic substance like hydrochloric acid, and you will liberate sulfur dioxide as a gas. This particular gas, unlike CO2, is toxic and does have a rather unpleasant smell. So typically we don't do this in labs, although it's not completely out of the question. Some classes do actually have you perform qualitative analysis where you do form SO2 as a gas. You also do form water and you also do form a salt associated with the cation of the base and the anion of the acid. Lastly, if you do start with ammonium salts like ammonium chloride, which are actually acidic by nature, mildly acidic, but they are acidic nonetheless, reacting with a base like calcium hydroxide, you will actually form and liberate NH3 gas, which has a rather mildly unpleasant smell. Not the worst ever, but it's a smell that you might have actually encountered in the past. In particular, ammonia is one of the reagents used in household cleaning products, so you might have actually, come in contact with it in the past. By reacting acidic NH4, ammonium, in other words, with a basic substance like a metal hydroxide will liberate ammonia gas. You also form water and you do form a salt associated with the metal of the base and the anion of the acid. Altogether, these are the acid-base reactions that you need to be aware of, and you also need to be capable of balancing each one of these reactions.